Hello everyone, today I'm going to show you how instead of advecting this height field with its current gradient and getting circles, you always get circles with this because that's just how it works. Instead, how we can get other shapes, like here it's triangles. If we change the sides to 2, we get like stripes. And if we change it to 4, we get squares. So I'll show how this code works, the basic mod behind it. I'll try and explain it a bit. And yeah. Okay, so like always, we start with the Geo node. We go inside, we get a height field. A height field, for the ones who don't know, it's just a 2D volume with 500 here, 500 here, and then 1 in the height. So we can add some noise to get a better viewing with all. Yeah, let's do stars, but blur them. So we basically have like circles. Oh, height field blur. So we have like circles and still add some noise, so we have more variation in the height. We can lower the octaves. Wait, I'll up this. So we have like more larger ones. We can set it to 2 so we get circles. So basically now we just have circles that are displaced a bit with some noise. I'll first show it here in the normal subcontext, and then I'll show you how you can do it in a solver. For more easily to see what is happening, I will first convert it to a grid so we can visualize the attributes easier. So normally you would use the volume gradient function in Vex, but here we can just do gradient of the height. Is there an attribute? Yes. For the ones who don't know, you can middle mouse click on a node to see the point attributes, and then if you control mouse middle click and then click on these things, you can visualize the attribute. So here you can visualize the gradient, but we want it on points. I call it grad. And we don't want the colors, so we want the marker with a vector. So we can see the vector is always going to the side where it's going up. So like here they all go up to the highest point they can find. They look basically in the area around them and look where the average position of higher points is, and that's where the vector will go. So like here, this is the highest area, this area. First, to get squares out of instead of circles by advecting. I'll show here how to the basics of advecting a height field. It's not really advecting, but it's like kind of, because it's the same like a VDB growth. So you start with the height field triangle, you get the gradient, so vector grad is volume gradient on the current geometry, so that's 0, and then the height volume, then the current position, and then we say height is equal to volume sample. That's just looking at the current position, what the height value is, and then setting that back to the height. So if you play it now, nothing happens because we're just looking at the same position. But if you look to the gradient, I'll also normalize it. So now we can add this gradient. It's basically like a velocity kind of that you add to the position. So if this is our point and our gradients are going like this, then instead of sampling just this position, we sample this position and get this height. So this height will become higher than it originally was. So if you play it now, you can see it's like expanding, and basically the highest points will take over most of the time. You can also multiply this by like 10 to get a faster result, probably. Not really faster because it's just sampling a point further away. Yeah, like now it's glitchy. But the problem with this is you always get like circles. Like here maybe you see kind of square shapes, but if you would change this, the Heightfield noise, just to the regular mountain, you see you get like circle shapes everywhere. And it's also cool, but it would be cooler to have like more control out of it. So what we can do is, maybe I'll just use this because it's more visible, or no, I'll just do this one. So I'll start here with the wrangle. So we have these gradients, and now these vectors go from everywhere, from like, if you would get a dot product of it with this axis, you would get the whole range like this. But if you want a square, you only want it to go like here, to the right, bottom, or left. So you get square shapes, not that it goes everywhere. So what we can do is flooring the value down. Wait, I'll show it. So first we'll say vector grad is equal to, normally you would do the volume gradient, but now we can just say grad because we created it with a measure sub. Then we'll create a variable I, and it's the amount of sides. Oh, say hi. Then like this. And then if you click here, you get a parameter of integers. So if you want a square, we can do it with 4 sides. Then we need to get the current angle with a vector we choose. I first thought to do it with the dot product, but the problem with the dot product is, I'll show it. So we get the dot product of the gradient vector, and we'll do the x-axis, and we'll fit it from 1, 1, because dot returns a value between -1 and 1 to 0 and 1, so can we visualize it better? Turn off this. So here it's basically kind of what we want, but the problem is if you would say it's smaller than, wait, up dot is up dot smaller than 0.7, 0.25, it's not exact, but it's to show. Now we get like both sides, and you would only want like a quarter, because if you divide 1 by 4, you would have like from 0 to 0.25, 0.25 to 0.5, but now you get like both sides. I don't know if it's clear, but I'll show you what we need to do instead. Important that this is a V, so we normalize the gradient. Just for good measures, we say we only want the x and z axis, so multiply the y. Then normalize it so it's a length of 1. Then, so the mask attribute is the atom2 of grad.x, grad.z. But then we get a value from -pi to pi, so we fit it from -pi to pi to 0.1. So then we have a value from 0 to 1. Then you can see here, if you would remove like this noise, you get like a nice attribute around your circles, because it just grows from 1 to 0. But because of the noise, it's a bit distorted. We here have the mask. Then we want to, because this is basically the angle, like if you would have the vector here, this is an angle of 360 degrees, this would be 270, 180, 90, this 45, it goes like this. But we want it to only be like this, one going up, down, there. And the best way to do it, I think, is what I did, and it is multiply your value by the amount of sides you want. So if you have 1 here, this is 1 times 4, you get 4. But if this is, for example, like here, it's say 0.8, and you do it times 4, you get 3.2. But we only want this number, not after the point, so we floor it to 3, and that's how we'll get like value here. This would be 0, here would be 1, here 2, here 3, and I'll show you how to do it. It's pretty easy. It's just So float mask is equal to the mask attribute times I, because that's how many sides we want. And then we need to floor this value. If I can remove this. But then we have a value from 0 to 3. So we want to fit it from 0 to I to 0.1. And then if we visualize this, we can see we get here is 0, here is 0.25, here is 0.5, and here's 0.75. If we look here, we can see 0.5, 0.75. We don't want to do it, we want to fit it from 4, because otherwise you would have 2 times 0 and 1, and that's basically the same amount of degrees, because 0 is the same, like 360, because yes. So then we have this. I'll renable this again. To do it like this, it's just pressing Q. You can also do W, E, and R. So then we have the floored mask. So then, now we have a value from 0 to 0.25, 0.5, and 0.7, but how do you get like your vector then? That's where sine and cosine comes in, because it's how you get like from a basic value you can get a vector, because you use the sine for the x and the cosine for the z, or inverse. That's how you can get a vector. So the sin is just the sine of floored mask, and then cosine of floored mask, and then vector floored grad is, we want to set it with sine, 0, and cos. So then, if we visualize that vector, we add grad is floored grad, then you can see if it's 0 it goes up. It's not correct yet, I think. Oh yes, so fitting it from 0 to 4 to 0 and 1, but we don't want the floored mask, we want the floored radians, because sine and cosine work in radians, and a full circle is 2 times pi of the amount of radians. So 1 pi radian is equal to 182 degrees normally, so we need to fit the floored mask from, we can do a fit 0, 1, from minus pi to pi. You could also do like 0 to 2 times pi here. So then the floored radians is basically, it's the same like the advent too, but then floored. So then if we use this instead of the floored mask, then you can see, maybe I need to inverse it so you can see it better. Here it goes to the left, here it goes up, here it goes to the right, and here it goes down. But you want it to go more in like you want to go it like this, because it just looks better, I think. Otherwise it would be like a weird sign. So what you can just do is here you can create a channel, or you can just add pi divided by 4, and then you get like the cross, because like I said, pi is equal to 180 degrees in radians, and if you want to offset it by 45 degrees, it's 180 divided by 4, so pi divided by 4. And then we have these cross factors, and if you change it here, you can set it to like this. You can get like even triangles with this. Okay, so then we have this. Like if you want 2 sides, you can also then, if you would want to, rotate it like this, or just So this one goes like to there, this goes like there. You can get full control with this, but we just want to do divide by I, and we want squares. Okay, so now we did it on the grid, but we want to do it on Heightfield. It's basically the same. I tested it out by just doing it like this, because you can visualize everything much easier. But you can basically just copy it, paste it in a wrangle, and then here also do it like this. Then just create the parameters like this, and I think, wait, nice. So the height is volume sample, the current height plus, oh no, v at p plus v at grad. So then, oh, it goes the wrong direction, so minus, and then you can see we get squares. You can also make triangles if you want, but because we started circles, maybe less clear. Let's test this with just a normal basic height field. Then you can see we get triangles. You could add a lot of more layers into this. Like even if you do two sides, you get like stripes, which is also pretty cool. You could do like 6. Then you get like hexagons. And you could still like, for example, change the strength of the grad. So if you look here, let's disable this. How you would do that is float. So here we have the mask, float, I'll call it mod, no, strength. It's equal to mask. Let's first look what that looks like. So this is just a basic 0 to 1 attribute. What you can do then, for example, is you can multiply it by your sides and then modulate it with your sides, but then you would still have the same outcome, but no, you need to fit it then from 0 to I to 0.1. So then you have the same, but if you do this times 5, for example, then you get the modulated version. So like here you could then, for example, also ramp this. Then you could start creating like different strings like this, or even if you want more random stuff, you can do like 10. And then, wait, if we get this, we paste it here, and we then do times strength. I don't know what we'll get now. Oh yeah, we don't have this. Probably, yeah, it's a bit more noisy. Let's do 4 here. Yeah, you can get a lot of different results. Like here, this also looks pretty cool. It's like something flowing down. Like you see, everything goes to one direction. Like here, it goes there, there. Or even if you want, you could even try and take the cross product of it. With like the up vector. I don't know what will happen now. You get like a complete different. It's like more dunes kind of thing. You got like small pyramids. Then you could say, what happens if I do two sides? Oh no, everything goes either that way or that way. So I would just suggest to play around with it. If you want to visualize it, you can just do it here in the attribute triangle. Yeah, just play with it. And this is just in one volume wrangle, but if you want, you can do a height field distort by noise and even distort it with like a bit of randomness. So yeah, now it's too much, but if you would do like 3 maybe, a bit less and larger, 1000. Yeah, you see, you just can get different results very easily. What's something else you can do? Height field, mask by feature, and if you get like the slope where it's flat, where it's mostly flat, wait, I'll remove the cross product here. I'll do it like this. So we just get our squares back. So now we get the squares back. Then we want to get a mask where it's flat. I'll remove these ones. maybe we can here add some noise then. So use a mask, do a blend maybe, then a cool noise is like these ones. Wait, yeah, like these square geometrical kind of patterns, maybe lower the octaves. Then you get a whole different result. Maybe it's not what you want. You can set the blend higher. I don't know what will happen. Maybe it's too strong. Also clear the mask. Yeah, then you have like stripes coming down. I don't know. Or you can do some distortion here. Yeah, like, and you get a whole different effect again with like these things coming down. No, it's just a bit too noisy, of course, but maybe add the distort back. It's just basically playing around and seeing what you can come up with. Maybe it's just, yeah, like this already looks a bit better. Yeah, like if you lower it, now you get like this thing. Like here it looks, yeah, it's a cool effect. It's like also modulating it. Maybe it's going a bit too fast, so what we can do then, maybe just multiply this with a lower value, like 0.5 or 0.6, yeah, 0.5. What happens if I multiply with 0.1? Then it's slower again. Yeah, so you can get some weird results probably with this, but remember the base of what we were doing was just this, but because it was very slow, yeah. Okay, so this, you could also do a Heightfields sharpen maybe. Yeah, like, you know, you get a lot more square patterns. And you can also change then like the inputs that you get, like, I'll just do some random stuff. Like this is a very random height field. And then bam, you get the square shapes again. Or even you could get the triangles. So yeah, that's that. I would just suggest to play around with it. Look if you can see some cool results. And it's just to get like more comfortable with facts and with attributes. Attributes you can just get with like a volume gradient, or even you could sample. Basically, sample is just looking at the current voxel and what value it has. So you could also do a mask and then a volume sample instead of the height. Add a mask here and use that as like a strength. There's infinite possibilities. Then you can also use the attributes. Like if you want, you could create a height field flow field after a sim. So you get these cool like veiny things, and then you could use that attribute in cops to shade your height field, or possibilities are endless. So yeah, that was just a quick explanation of how to affect height fields. If you have more questions, feel free to ask in the comments, and yeah, thank you for watching.